Okay, today Zieglar natta catalyst. The Zieglar natta catalyst was discovered by Professor Zieglar, German, and Professor Natta, Italy. When titanium chloride is added to triethylene aluminum in hydrocarbon solvent, yields bronze solid known as Zieglar natta catalyst. It polymerizes ethane at 1 atm pressure. The original uncatalyzed industrial process of polymerization of ethane has the use of high temperature and pressure. A Ziegler-Natta catalyst is a catalyst used to polymerize alkenes, olefins, such as ethylene and propylene into polymers like polyethylene and polypropylene. It's a high temperature alkene, ethylene is polymerized into n numbers. In presence of Ziegler-Natta catalyst, the polymerization can be carried out on the relatively mild condition at room temperature and low pressure. It produces isostatic, high density, harder and tougher polymers. For this work, Ziegler and Natta shared Nobel Prize for Chemistry in 1963. A typical Ziegler-Natta catalyst is a mixture, aluminum. The mechanism begins with the formation of complex between titanium and aluminum. Titanium tetrachloride and triethyl aluminum. Produces Ziegler-Natta catalyst. Ziegler-Natta catalyst is the catalyst used for the polymerization of ethane. The active species is titanium or titanium chloride formed in situ form, titanium tetrachloride and triethyl aluminum. Then one of the chlorine atom is replaced by ethyl group. The surface of the titanium atom has one of its coordination site is vacant. A possible mechanism is that the double bond in ethane attaches itself to vacant site on a titanium atom. On the surface of the catalyst, a force centered transition state is produced. Carbon shift reaction and ethane migrates and is inserted between titanium and carbon in the titanium ethyl bond. This extends the carbon chain from 2 to 4 atoms, leaving fresh vacuum site on titanium. Further molecule of ethane is then bound to the vacuum site and insertion process is repeated. The overall process is continued until a chain termination process occurs by serving of the titanium alkyl bond. Similar reaction occurs with ethane. Uses of Zieglar catalysts. Zieglar catalysts are mainly used for polymerization of alkenes to produce polymers with controlled molecular structure. Production of polyethylene used to manufacture high-density polyethylene and other forms of polyethylene. Production of polypropylene, widely used for produce isotactic polypropylene, which has high strain and good chemical resistance. Production of polybutene, used in the polymerization of 1-butene to produce poly-1-butene. Production of synthetic rubber, used for the producing polymers such as polyisoprene and certain types of polybutadiene. Steady regular polymer production enables the production of polymers with controlled stereochemistry, such as isotactic and syndiotactic polymers. Industrial plastics manufacturing, important in the production of plastics used in packaging pipes, containers, automotive components, fibers, and industrial plastics manufacturing, important in the production of plastics used in packaging pipes, containers, automotive components, fibers, and household products.